The effect of oxygen-resistant anaerobic bacteria on the concentration of nitrates and phosphates in polluted waters. Each year, roughly 300 million pounds of polluting nitrogen reaches the Chesapeake Bay, about 6 times the amount that reached the bay in the 1600s. This exponential increase in the amount of nitrates and phosphates that reaches the bay can be attributed to the people's use of nitrates and phosphates. Carpenter et al. 1998. Some algae can also trigger poisonous blooms to humans, but all algae blooms vastly decrease the amount of dissolved oxygen in the water. Nitrates and phosphates can be a good source for some plants as they lead to increased growth quickly, but it is an issue for algae as it causes these blooms. Once the algae die after the bloom, the bacteria will be needed to break down and consume the dead algae. These dead algae are consumed by microorganisms who need oxygen to survive. The oxygen level is thus highly decreased after the introduction of nitrates and phosphates, which causes widespread fish death and the collapse of the food chain. Nitrates and phosphates are formed naturally in the environment in a series of steps. Nitrates are an oxidized form of nitrogen and are formed by combining oxygen and nitrogen. Bacteria in the water changes ammonia to produce nitrate, which is then converted by other bacteria to nitrate. These nitrates are needed by plants to complete many of their daily functions, and the nitrates help the plant grow by supplying the necessary components to copy its DNA. The nitrates and phosphates then cause rapid growth in the algae. When the algae die, the aerobic microorganisms will break down and consume all the dissolved oxygen in the water in the process of breaking down the plants. After this, the only organism that will be able to survive in that ecosystem will be aerobic organisms, as there is no oxygen in the environment for the anaerobic organisms to survive. In Carpenter et al. 1998, it was found that the use of fertilizer and other nitrate and phosphate-rich sources directly lead to the increase in algae bloom occurrences around the United States and the rest of the world. These algae blooms have been found to kill off large numbers of fish after they die because of the BOD, or biological oxygen demand, drastically increases. Cyanobacteria are the main type of bacteria that thrive during an algae bloom, mainly because they are photosynthetic organisms that also feed off of the nitrates and phosphates. Carpenter et al. Found that the cyanobacteria that died after the algae bloom were the main food source for the resulting types of bacteria that fed on the dead cyanobacteria, or the dead algae. In Bergen Hamilton 2003, it has reviewed different pathways of nitrogen removal out of waters. One of these such methods is using anaerobic bacteria that eat the nitrates in order to reduce the amounts of nitrates in the water. The anaerobic bacteria must be anaerobic because aerobic bacteria would defeat the purpose, which is to increase the dissolved oxygen levels and allow fish life. The aerobic bacteria would also consume the dissolved oxygen to perform their functions. Bacillus subtilis was used because it is an anaerobic bacteria, but it is also oxygen resistant, which allows it to survive in the slightly oxygenated waters. Correll 1998 in his study found that the bacteria could be used to reduce the amount of biological oxygen demand and thus raise the dissolved oxygen levels. However, in this case study, they only used a small sample size and did not have an extended method. It must be explored why the reaction proceeded in the way it did, and why the Bacillus subtilis did not fully reduce the low BOD values and create a more oxygenated environment. The introduction of Bacillus subtilis into an algae bloom environment with chlorella will cause the biological oxygen demand to decrease and the dissolved oxygen levels to increase. The chlorella will need to be cultured in test tubes before it is exposed to the nitrogen phosphate environment. These test tubes will need to be washed out with hot water and soap beforehand to kill any bacteria that could feed on the culture solution. A small container of water will be used for this experiment, but the proportions of nitrates in the water will be the same as it is in the natural environment. There will be 4 groups in this experiment, 2 of which representing the control and 2 representing experimental. The 2 control groups will both be in healthy ecosystems. One of them will have the Miracle-Gro added to the solution and the other will not. The 2 experimental groups will have varying levels of Bacillus added to the waters. The first group will have low numbers of bacteria and the second group will have high numbers of bacteria. Both of the experimental groups will have the same amount of chlorella added, about the same amount that is found in most algae bloom situations. The dissolved oxygen levels will be measured with a dissolved oxygen level measurer, and the biological oxygen demand and the death rates of the chlorella will be measured to see how much oxygen is being pulled out of the water when the Bacillus subtilis are added. Overall, the aim is to see less dead chlorella material due to the presence of the bacillus that will be eating the dead chlorella material, and the dissolved oxygen levels will be higher due to the fact that the bacillus will be adding oxygen to its surrounding areas instead of taking oxygen away.